Hi, my name is Grace Wang and my mentor is Alexandra. I'm currently presenting in Redmond, Washington, the home of Microsoft. I chose to research ALS because I kept on getting exposed to it in TV shows and even English class, so I dove deeper. What I found interesting is that many well-known people who have gotten this disease are professional athletes, the most noticeable Lou Gehrig, whom this disease is named after. Therefore, I wanted to figure out why ALS seems so attracted to athletes and how physical activity might influence its development. Amyotrophic lateral sclerosis, or ALS, also known as Lou Gehrig's disease, as mentioned before, causes progressive degeneration of the upper and lower motor neurons in the brain and in the spinal cord. The motor neurons eventually die from the degeneration, and when they die, the brain loses motor control of the body. ALS is classified into two types: sporadic, which is around 90 to 95% of all cases and doesn't have any known cause, and familial, which affects around 5 to 10% of people with ALS and is thought to be inherited. Known risk factors include age and sex. For example, individuals ranging between the ages of 40 and 70 are at higher risk of ALS, and before age 65, men are more likely than women to get ALS. Usually when diagnosed with ALS, the disease progresses, often starting in the limbs and then spreading to other parts of the body. Symptoms may start from muscle weakness to muscle paralysis, causing a loss of motor control, and then by the end, those affected by ALS will have difficulty breathing, speaking, and eating. Progression varies, so the durations and paths will be different for each patient. On average, a patient with ALS will live for 3 years, and some may live for more or experience some sort of improvement. ALS is a very difficult disease to diagnose, as there isn't just one test to determine its presence. The diagnosis is based on multiple tests, including electrodiagnostic tests and muscle biopsies, to rule out other diseases before confirming ALS. Physicians will then determine the appropriate test to conduct based on the previous test results. Currently, there's no known cause or cure for ALS, but there are treatments and care, including medicine to minimize symptoms and therapy. So in general, physical activity can be split into two types: anaerobic and aerobic activity. Anaerobic activity requires using fast-twitch muscles, which use non-oxygen dependent pathways to produce energy for the muscles for high-intensity and short-duration activities, or vigorous activity, such as sprinting and high-intensity interval training. Aerobic activity, on the other hand, uses large groups of muscles simultaneously that require oxygen to produce energy for the muscles for cardio exercises, such as cycling, dancing, long-distance running, and walking. It's hypothesized that anaerobic activity is a risk factor for ALS, since the most vulnerable motor neurons supply the fast-twitch muscles for anaerobic activity. Case studies focused on leisure time activity in ALS showed that frequent leisure time and physical activity, such as muscle isolation exercises, was related to developing ALS, further expanding the thought that anaerobic activity is a risk factor compared to aerobic activity because of the fast-twitch muscle use. Additionally, in another study, comparing soccer players in different positions, this study supported this hypothesis by showing that those who played as defenders were more likely to develop ALS than those who played as goalkeepers. Defenders, coming into contact with the ball more, used more anaerobic activity compared to goalkeepers, who in an average game moved much less than defenders. However, these studies use surveys to collect data, increasing the susceptibility of referral and recall bias, as normally it seemed to be better to be more active. Mouse models show different effects of exercise on ALS mice. So for example, swimming was shown to produce beneficial effects delaying disease progression and producing neuroprotective effects, such as delaying and preserving motor neurons with large soma area. Swimming is a high movement amplitude and frequency exercise, and it activates large motor neurons that belong to fast motor units. Additionally, swimming preferentially protects medium-sized motor neurons in the spinal cord. This suggests that exercise-activated neurons are selectively protected against cell death and become more resistant to apoptosis. In contrast, running didn't show these effects and also led to motor neuron loss. This may be because running is a low movement amplitude and frequency exercise, which requires slow hind limb movement, activating small motor neurons that belong to slow motor units. Another study showed that male mice, when put in treadmill endurance training, had a greater increase in life expectancy than female mice, suggesting that testosterone levels and increased muscle mass are protective in ALS. However, female mice showed disease delay, suggesting that female hormones show a neuroprotective effect. The same study showed that moderate intensity exercise increases the longevity of mice compared to high intensity and sedentary exercise. So that's all. Thank you for listening to my presentation.